Whoa. She doesn't get
Who's there?
You're up here.
On our heads.
So I'm just going to draw the result up here.
That's a pretty good like. I'd be like, kudos. Who made that?
Party City.
Party City. Oh, Party City.
I just go in there sometimes and just look at all the candy. It's so pretty.
Okay, we did in class graphs of 2 to the x and 3 to the x. We did this a couple of weeks ago. Okay? And I think it was assigned. And I think those who are doing the homework have done it. So I'm going to use the blue chalk, Emily. Get your binoculars. But I'll write big. No, you don't need to come up. I'm going to write big enough that you'll be able to see it. Okay? And like what I did in the MCR. Okay. Where is e to the x going to be?
Right, kind of in the middle.
Well, e is between 2 and 3, so the e to the x graph will be between the 2 to the x and 3 to the x graph, right? Now, when we did it before, I told you e was about 2.7. I didn't tell you why. You got a better idea why after figuring out some of the process we did. So it's probably going to be closer to the 3 to the x graph than the 2 to the x graph. Can you read that?
Yes.
Good. I know blue's hard to read. I was reading a magazine yesterday. It tries to be edgy. It has all kinds of background colors and foreground colors in the print. So it does like yellow and light green.
Yeah.
And you know, my eyes are really pretty good, but I need daylight to be able to read that stuff. Okay? Even with reading glasses. Okay, anyhow. There's a little perspective in the graph of e to the x. Okay? Now there's one really neat thing about e to the x.
E to the x.
If you do a tangent line at some value of x, well, first of all, let's just say, okay, if there's x, then the y value over here is e to the x, right? Okay? If you calculate the slope at this point, the slope of the tangent line tangent line is just a line that just touches the curve at one point, right at this point. And the curve is curving upward like this, so it curves into that point here and then away from that point. So the tangent line never goes through the graph, it just touches the graph. And I did a fundamental triangle on this, just to indicate we want to think about the slope of that tangent line, right? So we have the point x, e to the x. That's the coordinates of this point here. So what do you think the slope is? Well, you wouldn't know. It's the same as the value of the function. The slope is the same as the y value. That's a big deal. Okay? It's why we call this the natural exponential function. Okay? Function comes naturally from considering compound interest, if you like, but also the function that gives you a slope that's equal to the value of the function at every point. Okay? Which makes it really easy to do calculus with the exponential function, because the first semester calculus is all about the slopes of tangent lines. Okay? Now, you don't have to know any more than that. I'm giving you the background for calculus, or trying to, okay? So we go right up to calculus, but we don't go into it, okay? There may be a little ways we do some difference quotients, which we'll do before too long, okay? So you have something to look forward to. Okay, that's an important property, so it's worth kind of thinking about and maybe remembering, especially if you think you might have a calculus course in your future. It'll help you understand things that you would not otherwise be prepared to understand.